Shell and tube heat exchangers are very versatile and provide large ratios of heat transfer area to volume. An example of a shell and tube heat exchanger is shown here.
For this particular design, it was requested that the pressure drop be minimized and that the temperature difference across the tube does not exceed 3 degrees Fahrenheit. It was given that water flows out of the reservoir and into the tube at 57 degrees Fahrenheit. The heat to be dispersed comes in as a liquid at 90 to 100 degrees Fahrenheit. The temperature difference for the shell should be found as the difference between 100 and 70 degrees Fahrenheit, or a difference of 16.7 degrees Celsius. The HPC computers generate about 1 megawatt of thermal energy, so the heat rejection was to remain at about 1 megawatt to eliminate this heat being given off by the computers.
It was found that the change in outer diameter of the tube and length of the tube had the largest effect on the pressure, so these variables were altered to find the most optimal result. The two graphs display the effect that these two variables had on the outlet temperatures, both of the tube and of the shell. It is important to remember that the tube outlet temperature must remain below 15.5 degrees Celsius, and the shell outlet temperature must stay between 21.2 and 26.6 degrees Celsius.
Here you can see the relationship between the two variables and the heat rejection. It is important to keep the heat rejection close to 1 megawatt, as shown by the red box.
The effect that the tube diameter and length have on the pressure drop is shown here. It was requested that these pressure drops be minimized.
This graph shows the number of transfer units versus effectiveness. The three lines represent varying values of CR, which is the heat capacity ratio.
The chosen design parameters for the most optimal design are shown here. A single-pass heat exchanger with a triangular pitch configuration was designed. An outer tube diameter was chosen to be 0.12 meters with a tube length of 6 meters.
The estimated cost for this heat exchanger is $100,000. This price is only an estimate due to the custom work that will need to be done by the company. Manning & Lewis Engineering Company is a potential supplier for this heat exchanger. They are custom designers and manufacturers of shell and tube heat exchangers made of carbon steel, stainless steel, and aluminum.